Today's lesson is over converting repeating decimals into fractions. This is a tricky concept that I normally teach in class in person, but we'll have a few days of practice work on this, so if the lesson is not clear, I'll be there to help you as we practice this moving forward. Let's give it a shot. So we're going to convert repeating decimals into fractions. We're going to start with one we all know. We know that 3/10 repeating is 1/3. Okay, I'm going to show you why, so we can then apply those concepts to fractions that aren't as well known to us. So what we're going to do, we're going to start by just creating an equation. We're going to set the decimal equal to a variable, and I'm going to choose x. We just write that up. That first step is pretty simple. But now here's where we get a little funny. All right, we're going to multiply the decimal by a multiple of 10. So that the repeated part of the decimal is the only part to the right of the decimal point. That's pretty wordy. Let me show you what that means. Sorry, I did not want to do that. So when it's one number repeating, it's not that bad because all we have to do is multiply the decimal by one place. So if we move a decimal point over one spot, we're just doing it times 10. So if we multiply both parts by 10, we say that 10x will equal 3.333 repeating. So to the right of the decimal point is only the repeating stuff. We multiplied the original amount, x equals this, each side by 10. So we have 10x equals 3.333333333. Now what we're going to do, we're going to subtract the two equations from each other. We're going to make sure we end up with a positive difference on each side of the sign. So we set up our 10x equals 3.33333 on top, and then the original value on the bottom. We subtract each part of the equation. So what's going to happen when we take this away? 10x minus x, we're left with 9x. 10 minus 1. And then over here, what we've done is try to cancel out the repeating part. So we've got 10, we have left with 9x equals 3. And then from there, it's a one-step equation, which I expect you to know how to solve from last year. So 9x equals 3. We divide both sides by the coefficient to eliminate it. And we're left with x equals 3/9, which in lowest terms we should know is 1/3. So steps 1 and 4 aren't bad. 2 and 3 is where this is tricky, and we're going to do a few examples going forward. If you think you know this, you can go ahead and pause the video anytime you want and try it out on your own, but I'm going to walk you through it. So let's start with this one, 6/10 repeating. So our first step, remember, is set x equal to that value. And all we've got to do is multiply each side by 10, because that will move our decimal point over one place to give us 6.66666 repeating. So we have that. Now we subtract our original setup from the multiple of 10. And we're left with, this is a different color theme going, 9x equals, well, that goes away, just 6. Catch for the subtraction signs there. So we divide both sides by 9. We have 6 over 9. So I should probably write that up. I'm going too fast here. Which gets us to 2/3. That's another common one, okay? 6/10 repeating is 2/3. There we see why. A little less common, but not too difficult if we have a hang of this, is 7/10 repeating. So we'll start by setting that equal to x. Multiply each side by 10. Now we have 10x equals 7.777 repeating. We'll subtract our original amount 10x minus x equals 9x. Those go away, so 9x equals 7. Leaves us with x equals 7/9. So with one number repeating to the right of the decimal point, not too bad. How about a number like this? So now we've got 1300ths repeating. So our first step stays the same. Now, if you recall, we want to get our next step. The point is to make only the repeating part to the right of the decimal. So our 1300ths, we need to have 13 as repeating on the right side. So multiplying by 10x won't do it for us. It only gets our point over one place, which would give us, 1.313131, and we want the 13 to be the repeating part. So we need our decimal point to move over 2 places. Okay, we have to get it over 2 spots. And to do that, so that should be behind the 1. To do that, we multiply the original by 100x. Because that'll give us 13.131313 repeating. So we set up and subtract our original from this. If you want, I'll show you in class why we don't do it just by tenths. If you can't figure out, which is okay. I just don't want to take too much time on the video and really overload you. So what we're left, I'm writing this wrong, I'm sorry. We're left with 99x on the left side equals 13. And then we just divide both sides by the coefficient. And we have x equals 13/99. If you want to check any calculators, do 13 divided by 99. I guarantee you will get the repeating decimal we began with. So if you haven't tried on your own yet, go ahead and try these on your own. And so pause the video and come back to them when you're done and see if your answers match mine. So I'm going to start here with x equals 4/10 repeating. It's just one digit, so make the next line 10x equals 4 and 4/10 repeating. Subtract our new one from our original. And we've got 9x equals 4. Divide both sides by that 9. So we're left with x equals 4/9. Now we've got a 2-digit repeater over here. So we've got 4500ths repeating. So that's our original. Since we have 2 digits, we want to get that 45 as the repeating part. So we'll multiply each side by 100. Subtract our original from that. Then we're left with 99x equals, and that's all gone, 45. So x equals 45 over 99. Fractions always belong in lowest terms, so we can divide both parts of this fraction by 9. To leave us with 5/11. There's our final answer. Again, guarantee you in the calculator, 5 divided by 11 equals our original repeating decimal. This concludes tonight's lesson.